If you missed part 1, go watch it right now. I'll wait.
2,000 years later.
Back? Good, because part 2 is where things get really interesting. We're talking about the force that keeps planets in orbit, the rule that says energy never dies, and why a truck will always win in a collision. Let's go. Right now, the Earth is pulling you toward its center with everything it's got. And you're pulling it back. Yes, you. Every single object in the universe with mass pulls on every other object with mass. Newton put it on paper with the law of universal gravitation. Bigger mass, bigger pull. More distance, weaker pull. But it doesn't get weaker slowly. Gravity drops by the square of the distance. Double the distance, gravity becomes 4 times weaker. This is the inverse square law, and it's why astronauts feel weightless even though they're only a few hundred miles above Earth. Quick thing people always get wrong. Mass is how much stuff is in you. Weight is gravity pulling on that stuff. Weight equals mass times gravitational acceleration. On the moon, you'd weigh 83% less. Same body, same atoms, just a smaller pull. So technically, you're not overweight. You're just on the wrong planet. The sun is so massive that its gravity constantly pulls the Earth inward, but the Earth is moving sideways so fast that it keeps missing the sun, falling toward it, missing it, falling, missing, forever. We call that an orbit. Gravity and momentum having an argument that never gets resolved. Now let's talk about energy. You know the thing kids have at 11 p.m. that nobody asked for? Energy is just a number sitting there as a property of something. Its unit is the joule. 2 main flavors. Kinetic energy. Energy of movement. Anything moving has it. On paper equals half times mass times velocity squared. The faster something moves, the more energy it carries. A lot more. Potential energy. Stored energy, waiting to happen. Hold a ball above the ground. Equals mass times gravity times height. The higher you hold it, the more stored energy. Let it go. That stored energy converts instantly into kinetic energy on the way down. Now, work. Work is force applied over a distance. Ever tried lifting a weight too heavy for you? Struggled, strained, gave up? Physics doesn't care. Mathematically, you did 0 work. No movement, no distance, no work. Your feelings are invalid in the face of equations. The most important rule, energy cannot be created or destroyed, only converted, always. And power? Power is just how fast you're doing that work. Power equals work divided by time. Same job, done faster, more power. Energy, work, power. 3 ideas. 1 chain. What happens when 2 things collide? That's momentum. Momentum equals mass times velocity. A truck doing 5 miles per hour and a tennis ball doing 100 miles per hour. Completely different momenta. The truck wins, every time. But here's the powerful part. Momentum is always conserved. Total momentum before equals total momentum after. Collisions come in 2 flavors. Elastic, objects bounce perfectly. Think billiard balls. Clean, satisfying, no damage. Inelastic, objects crumple, stick, deform. Think car crashes. Not clean, not satisfying. Very expensive. Momentum, always conserved. No exceptions. Everything we talked about was straight lines, but most things in the real world don't move in straight lines. They spin, wheels spin, engines spin, the Earth spins. Your head spins after trying to understand your electricity bill. Everything in linear motion has a rotational twin. Velocity becomes angular velocity. Mass becomes moment of inertia. And force becomes torque. Torque is a rotational push. Equals force times the distance from the center. Ever struggled to open a tight jar lid? You instinctively grab it as far from the center as possible. The further from the center you apply a force, the more rotational power you get. This is why a wrench works. A long wrench on a stubborn bolt beats a short one every time. Same hand, same force, just more distance. Engines, turbines, windmills, bicycle gears, all of it is just torque doing its job quietly in the background. From lazy objects that hate being disturbed, to spinning engines, to planets falling forever around the sun, it's all one thing: classical mechanics. 3 questions. What is moving, how fast, and why? Now you can answer all 3, see? Simple.